So I wanted to go back and just kind of review a couple of quick things from last time, just so we're all on the same page, and then we'll continue. So we were talking about string variables, which of course you've used. And as you guys have been noticing in your tokenizer while you're working on that, you need to be able to carve up a string into various pieces, okay? In BASIC, you've got three functions that'll allow you to do that, which are left, mid, and right. And mid you can use to basically pluck off any specific character of a string, starting at a given index and ending at a given index. And left and right work similarly for returning substrings. So for example, for a basic program, right, the first two characters are the line number, and then there's a space. So the left you could use like to pluck out. So let's say you had a string that contained a basic line. You could pluck out the first two parts of it as the line number and go from there. Okay. Okay. So the indexing, as we said, starts with 1 rather than 0, like in pretty much every other language we've dealt with. It makes sense why you would do this for beginners, but whatever. The part that you carve out can be a single character, which is really just a string of length 1, or it could be actually, a string with lots of stuff. And then, as we've discussed, anything that relates to strings in any way, shape, or form, variables or functions are going to have the $ at the end of them, just to indicate that it's a string. Yeah, okay. And then, you guys did input and output with these things with print or the input function, right? Okay, so that's not horrible. As we said, there's a couple of functions for doing conversions. You can do string of a number, which will convert a number to its string equivalent, or you could go the other direction. So basically, you've got string to float and float to string. In BASIC, all numbers are floats. Even if they're integers, it just will truncate off the unnecessary decimals, which is both nice and annoying, depending on how you want to look at it. The annoying part is, so why would it maybe be annoying to have floats on the old Commodore and do everything in floats?
Floats are like more complex, I feel like, than integers.
Yeah, definitely. They take more data to store. And in particular, does the Commodore have a hardware floating point unit? No. So all of that floating point arithmetic and handling is all done in software, which means it's slow compared to hardware, right? Yes. The other thing that's maybe, it's not really the end of the world, but it's mildly annoying, is the exact way that the number is stored in memory is not the same as the IEEE 754 format. Okay, so you remember in 241, we talked about how 32 or 64-bit floats are stored. It's not exactly that way. The sign bit is not at the beginning. Okay, whatever. The exponent bias is different, and the number of mantissa bits is different. So it's mildly annoying that that's the case, but whatever, right? Now, the reason for that actually is kind of important, right? Because Commodore Basic, the stuff we're looking at is, late 70s era programming, right? So, we're using code written by Bill Gates himself, essentially, or some of it anyway. In the late 70s, there was no standard floating point format. So the IEEE format, that was only ratified for the first time in 1984. Well, the Commodore was released in 82, right? So the industry was starting to kind of coalesce around a standard, but it wasn't yet there wasn't yet a standard until later. Okay, so yeah, so all the floating point routines are handled in software. And from the user's perspective, these machines are fast enough that you don't really notice, but they are all technically floats. Okay, so and then if you've got a specific number that you want to turn into a character, then you can do that with the ASC function. The one exception to this would be that you cannot do the empty string. If you wanted to do that, you'd have to do car of 0. Okay, so yeah, so just keep that in mind. And right, okay. So file types we talked about that. There's really 4 file types that the Commodore sort of thinks of. PRG, which is either a basic program or it could be machine code. And for the basic programs, which is what we've done so far, right, they follow a very specific format. They have to get loaded into a particular address in memory. The first 2 bytes say where in memory they have to get loaded, which for a basic program is always 0801. This is how the machine knows that it's a basic program to start with. And then for a basic program, it's kind of a hex dump, but as we've seen, there's the details about, well, there's some tokens and there's some the pointers and line numbers are in specific places, right? So it's not just a hex dump, but it's sort of, there's some encoding to it. For machine code, it's just code. The first 2 bytes are where the thing gets loaded, and then it's just code after that. Just like it was in 241, right? Now, in 241, we didn't very often look at the actual machine code and encoding of each instruction. We were thinking one layer up in the assembly, but there were a couple of occasions where we did look at the machine, like the actual 32-bit encoding of a given instruction. It just wasn't very often, right? So and one of the reasons, of course, is because on ARM, right, 64-bit ARM, there's a gajillion different instructions, and there's just way too much to keep track of. On the machine language instructions for this processor, there's 100 and something, right, which is not that horrible to kind of keep up with because they're actually organized into, there's a lot of related ones, for example, for loading, right? And they all kind of look similar. So, right, those 140 whatever can be kind of condensed down into some families. Okay, so the program file, sequential or user files, which are basically just plain text encoded in PETSCII, and with line breaks usually being 0Ds instead of 0As. That's caused me a little bit of a headache. Relative, which is it's almost like a primitive database, and I haven't really found any good documentation on how to use it, but you could like have data accessible by record numbers and maybe program like almost like a simple little database to get, customer number 1, what's their name, what's their address, etc. But like I said, I haven't really found very good documentation on exactly how that stuff works. Line terminations, okay, because this is going to be a problem, right? In BASIC, how do you know that you've hit the end of a line? You hit the double null terminator, or the null terminator, sorry, right? And then how do you know you've hit the end of the program? You hit a single line, a null terminator for the end of the line, and then a double one for the end of the program. So it'd be 3. 3 in a row. The first one is the end of the line, and the second and the third are collectively the end of the program. Yeah, okay. Modern text, if you're using, any text editor, it's going to end the lines with the end of line character, which is 0A. Um, and I suppose there might be text editors, like if you use like VI or Emacs or something, I don't know, that maybe carriage return it instead of line break it. Um, the one issue that you may run into with your tokenizer is, so what text editor are you guys using for writing code? What do you guys, Genie, Atom, VS Code, which one do you guys like to use? Notepad, Notepad plus plus, or just Notepad? Wow. Okay. So the reason I mention this is because it might vary whether or not the last line of your program is going to have an end of line at the end of it. Okay, so because I tried this with both Genie and Atom, and one of them did put an end of line character at the end of the last line, and the other one didn't. Okay, so you, depending on your tokenizer, that last line you may need to look for either the end of line or the end of file marker. Okay, which, right, when Giancarlo, so VS Code does not put the end of line unless you hit enter and make a blank line at the bottom. Okay, so that's just one thing to keep in mind, is that you may have to also look for the end of file marker. And depending on which language you're doing this in, that, you know, how exactly you designate that is different. So John's doing it in C++. I would do this in C. I imagine everybody else is going to do it in Python. Yeah. Have we made any progress, by the way, on our tokenizers? Staring at you with angry glares. Okay. Does it work? Can you drag your program file into Vice and it works? Okay. Pointers, line numbers. Okay. Oh, you literally just drag the file into a Vice window. So I'll show you. Yeah. Well, or you can put it into D64 and load it the usual way. But yeah, so I'll show you that trick in a second. Okay. So yeah, on the C64, the lines are like, if we had a program, a text editor program, it would usually null terminate, or sorry, not null terminate, put a carriage return terminate rather than line break. Or in the case of a program, of course, there is no real line termination. It just is more code. Okay. Okay. So in BASIC, in the same way that you could do this in Python or C or whatever, you can open files and write to them or read from them. You can do this in BASIC too. Okay. So here's the syntax for it. You can have 8 files open at a time. And each one is going to get a logical number, which basically is just a shorthand for it. So you can open whatever file you want as file number 1. And then anytime you want to read or write from it, all you have to specify is the number 1. That's convenient. Okay. And so you could do open, and the syntax for this is 1, 8, something. And then in quotes, you've got the file name, a type, which will either be PRG, SEQ, etc., and W or R for reading or writing. Okay. Now, the 1 specifies the logical file number. So that's going to be a number from 1 to 8. The 8 specifies which device is it going to try and open the file from. Okay, so what is device 8? Yeah, your floppy drive, your disk drive. If you had more than one floppy drive, which later on in the Commodore era people would have more than one, then it could be 9, 10, 11, and so on. 4 was the default device for a printer. So you could print things by opening it for writing and then sending data to the printer, and it would actually print it out on paper. Yeah, okay. Now, the 4, there is what's called a secondary channel or a secondary address. And there's a couple things about that. They can be numbers 1 through 15, except you can't use, for the most part, you should not use 0, 1, or 15. 15 is the channel that you send commands to the device. 0 and 1 are reserved for loading and saving. Okay, but otherwise you can pretty much use whichever one you want. And if you have more than one file open, you want to use different subchannels for each file. Okay, so it doesn't really matter which one you do with which one, other than that they should be different. And the documentation on this is not really all that great, what all the different secondary device IDs do. But for example, with the printers, one of the things you could do with the secondary ID was specify whether to print in all caps or in lowercase. And then the printer would print the data, accordingly. And then, of course, I said that 0, 1, and 15 are special. We'll talk about those in a minute. Okay, so anyway, just use a different one for each file. For the program the next couple of programs you're going to be writing, there's really only going to be 2 files open, so this really isn't a huge problem. But yeah.
What's the point of the 4 then?
So the point of the 4, or I could have made it 3 or 2. The number itself in this case doesn't matter. It allows you to do sort of secondary functions. For reading and writing from a disk, it doesn't matter. But for like using a printer or some other devices, it can. Like I said, I have not found a good list of every secondary device with every primary device and what its function would be, which is mildly annoying. But yeah, for our purposes, what you guys could do is just always open files as number 2 and 3 logically, and then use channels 2 and 3. Because you're going to have one open for reading and the other open for writing, right? And that's it. Okay. Okay. So similar syntax for writing or reading. It's W versus R, and the logical file number is just a placeholder. At the end of the program or wherever in the program you're finished with the file, make sure to close it. If you don't close it, or you run a program and the program, say, you halt the program before it gets to the close, then what will happen is that your file will be called a splat file, and it'll have a little asterisk next to it when you load the directory listing. And it basically means the file's been opened but hasn't been properly closed. So that's not a good thing. Okay. Now, for reading, it's not really going to matter because you're not changing the data, but for writing, that could cause problems. So just make sure to close the files after you use them. You can, if you put an @0 colon in front of the file name, you can overwrite the file. But what's better to do here is actually to delete it and then reopen it from scratch. Okay. And yeah, the way you can delete a file is if you open it, okay, and then you prepend the file. Well, if you open it on channel 15, that's the command channel for a disk, and you put S colon in front of the file name, this is going to do a couple of things. It's going to send, what you're doing with device or subchannel 15 is you're sending not data to the disk, but actually a command to the disk. And the S command stands for scratch, which means delete. Okay, so what this is telling the disk is, hey, open this file, delete it, and then close the file. Okay. And then, so if I wanted to write a program that, say, for example, opened a file for processing, read it, and then outputted other things to a different file, what I would do at the very beginning of the program is delete the output file and then immediately recreate it. Okay. Now, why is that maybe a good thing? Yeah, and the reason I would maybe do this is because this is something I ran into with a test program I was writing, where I overwrote the file, but the original file had like the new version was shorter than the old one. And so what happens is it overwrote all the bytes up to some point, but then there was still the tail end of the original version. And I didn't want that, right? So by deleting it and then just remaking it from scratch, then I don't have this problem, okay? Yeah, so that's sort of a mild annoyance, but c'est la vie. Okay, so yeah, the secondary address for the most part you don't really need to worry about, except it can't be 0 or 1, and 15 you only use for disk commands or IO, like error stuff. So like deleting, we sent a disk command, hey, delete this thing. And otherwise, it's just important that the secondary addresses be different for each file that you're using, which is, yeah, whatever. Okay. Yeah, okay, good. Yeah. All right, so if we want to read or write from a file, then there's two ways we can do it. We can use get hash or input hash, okay? Um, input hash will pull in a line of up to 80 characters, and get will just pull in a single character, okay? And if the character that it's pulling in is the null terminator or the null thing, then it will return that, but it will return the null string, which we've seen could cause issues. Okay, I'll show you an example of where we have to worry about this later. You can write to a file character by character using print, okay? Or you can actually write an entire string at once. Both are useful, obviously. And the what's the semicolon do, right? So if you put a semicolon after a print statement, what does it do?
Well, there was the one where like it just kept going, but it didn't stop.
Yeah, so
Like
yeah, if you put the semicolon, it suppresses a carriage return at the end of the print. If you don't put the semicolon, it will put a carriage return. So if you're writing to a file, you, depending on what you're writing or how you're writing it, you may or may not want to throw a carriage return at the end. Okay, that just depends on what kind of data you're working with. If I'm trying to, like, let's say, for example, I wanted to write a basic program that tokenizes a basic program. Could we do that? Yeah. Okay. In which case, I wouldn't want there to be carriage returns getting thrown into the middle of my program file, would there? Would I? Okay, so there I'd want to make sure that I use the semicolon to make sure that I'm not putting in extraneous carriage returns that are going to screw everything up. We? We know. Okay, good. All right, so, and we'll look at an example of this in a minute. Okay, so this is a slide I added since last time. And how do you know you've hit the end of a file? Okay, possibly. For a basic program file, yes, you'd hit triple null. But if it's a text file, just a sequential that just has stuff in it, how do you know that you've hit the end of it, right? Or at least in basic versus machine language. Okay, so the way that you can do this is because we're reading from a device, there is also this variable called status, or ST for short, that you can read from, and that will tell you if you've hit the end of a file and a bunch of other things. Okay, so now the status variable, it's an 8-bit number. Okay, and each of the bits means something. The bit that we care about is the 64's place. Okay, for end of file. Okay, which is bit number 6 out of 7. Right, so because the 7th bit is the 128th place, right? And the 0th bit is the 1's place. Yeah? Okay, so if I wanted to check whether or not I've hit the end of a file, I can look at the status variable, and if I only care about a specific bit, then I'll mask it by ANDing it against the place value of the bit that I care about. Okay, so for example, if I care about the end of file only, then I'll mask against 64, which is a 1 in the 7th bit position. Okay, so if I AND the thing against the number 64, then I will get exactly 2 results. I'll either get 0 or 64, right? And if I get 0, that tells me one thing, and if I get 64, that tells me another. Okay, so does that make sense? Now, the other bits are useful for other things, but for end of file, it's the 6th bit that we care about. The other ones are for other purposes. The wiki's got a list of all of them, and also what the status thing does. So the status variable gets updated immediately after a read, and it depends on which device you read from. So which bit represents what information for which type of device is different, and you just have to look at the documentation to see the list. Okay, so in particular, the printer status variables versus disk drive status versus tape drive or screen or serial port, right? So there's lots of different devices. What each bit means depends on which device you're looking at. Okay, for our purposes, we're looking at serial devices, which is to say the disk drives. It's bit 6 that we care about for end of file. Okay, so, okay. Now, I should mention, because when we transition to machine code, this will be relevant. The status variable, it turns out, is really just a single byte worth of memory. And it's at location 90 hex, or 144 decimal. So you could also peek that value, that memory address, and get the same data. And what that means is that when we throw BASIC away and we start doing things in machine language, what we'll actually do is, rather than using the status variable, we'll just go to that memory address directly and say, hey, what's there? Okay, but in BASIC anyway, the status variable is convenient. Okay, and it's called status, but remember the variable names, it really only uses the first 2 letters of them, and so ST is for short. Okay, good. So let's look at an example of a stupidly simple program that all it will do is copy a file. Okay, and so let's suppose that I want to copy a file that starts as, it's called myprog, and I want to write the copy of it to newprog3. Okay, and I just made up those names for the sake of testing. But obviously they could be whatever. Okay, so what do the first 2 lines mean here? Yeah, open the first one for reading, and it's myprog is the name. It's of type what? P for PRG. So you don't actually have to give the full file type. You can just give the first letter of it, because there's only 4, right? P, S, U, and R. Okay. And then R and W for read and write, obviously. Okay. And I'm opening these on logical file numbers 1 and 2, and subchannels 8 and 4. That there's no real reason for picking them in that order. I just did it. There had to be something, right? And then why are they both have 8s in the middle? Yeah, because it's on device 8, the default floppy drive. Okay. All right. So all of those 2 things, just open the 2 files, one for read, one for write. And then at the very, very end of the program, what do I have? Right. So I need to close both of them, and then I didn't need to put end here, but I went ahead and did it just for.
500 good practice.
Well, it's because when I started writing it, I didn't know exactly how many lines I was going to have, and so I was just like, I'll just make it 500 because there's no way it's going to take that many lines. And then I could always go back and change this to 80 when I'm finished. But I just made it 500 just so that I didn't have any.
If you wrote like one through 50 or 10 through 50 the same, and then you wrote line 500 after 50, and then line 60 and then line 70, would it order itself?
Yes. Yes. So if you were to type this in, and this is, remember why it's so nice that we're leaving a gap, because you could write line 15 and it'll put it in between line 10 and line 20. So you can, this is really nice on the, right, because you have to remember, when you bought a Commodore back then, right, if you went to the store and you bought one and you didn't buy a disk drive, what software did it come with? The kernel ROM and BASIC. So you'd fire it up, and it would have a little blue screen that said, 37,000 whatever basic bytes free. That's it, right? No games, no text editors, no calculators. All you have is basic. Okay. If you wanted to have extra stuff, go back to the store. Okay. Huh? Yeah. Well, I don't know. I mean, now that said, later as the market developed, Commodore did start in bundling in disk software, and bundling. You could buy like a combo pack that had a disk drive. It had some software. It had the computer, right? But that was not the way they were sold originally. And in particular, the disk drives were extra because those were expensive back in the day. And so when this machine was first released in 82, most of the software that you were going to use with it, you'd buy on a cartridge, not on floppy. And as the price of the floppy drives came down and they were more accessible, then you started to get more software coming on floppies and most stuff not coming on cartridges anymore, right? Because what's the advantage of floppies versus cartridge? Couple of them. Like a Nintendo cartridge, literally, yeah. Looks,
I'm guessing you have more storage?
Yeah, more storage, okay. Because a cartridge could at most, well, yeah, more storage, and also you can write to it, whereas a cartridge you can't. It's read only. Well, okay, that's a good question. Because of the type of memory that's in a cartridge, being able to write to it was uncommon. And in fact, let's think about Nintendo games. Well, okay, good question. Why would you want to be able to write to a cartridge if it's a game, for example?
Oh, that was an actual question.
Yeah.
I guess if I think about it, like, why would I want to change my video game? I don't think I would.
You wouldn't. You wouldn't want to change your video game, but you might want to save some data, like your progress through the game.
About writing.
Yeah. Okay, so on the Nintendo, for example, did anybody ever play well, okay, did you guys ever play an original 8-bit Nintendo? Yeah? Or a Super Nintendo? Yeah. Did you ever have a game that had save data? Like Final Fantasy, for example, that was the first one I had that had save data. Okay, so that was different, right? So, like, let's take, for example, Mega Man, right? Okay. Yeah. They teach you psychic powers in teacher school, right? Okay, so Mega Man. You guys played this game? No? Oh yeah, God, it's great. It's yeah. So, okay. In this game, there were different bosses and different levels, and one of the things that was unique about it is that you could play them in any order. But whichever order you played them in, there were some orders that were more optimal than others. Okay, and that was part of the game is to sort of figure that out. Well, so it did not have the ability to save data to the cartridge. And so what it did instead is when you finished a level, it would give you a password. And if you started the game back up and you put that password in, it would decode it and know what items and stuff you had and what order you had gone through the game up to that point. Okay, so that's how they got around not being able to keep your progress from one play session to another without actually having to write data to the cartridge. Okay, um, so now other games that were more complicated. Final Fantasy was, like I said, the first save game program that I ever had. I think maybe one of the Legend of Zelda ones probably did, but I didn't play. I didn't have one of the Zelda games until uh, Link to the Past on Super Nintendo. That was the first one I owned personally. Um, and the way those worked is that there was actually a tiny little battery inside the cartridge and a small chip that had just the storage for the save data. And anytime that the game was plugged into the computer, it would charge or to the console, it would charge the battery up. And then that battery would last for a year or something and preserve your data. Um, yeah, I am not aware off the top of my head of any cartridges from back in the day that had battery backup stuff like that. There probably were for the Commodore and other machines, but I can't think of one off the top of my head. Oh yeah,
Looks kind of cool.
yeah, it's sweet. This was a really cool game.
I like how it like shifts the screen kind of.
Yeah, I think Metroid kind of got the idea from that. Part of it's also hardware limitations of the Super Nintendo, I mean of the Nintendo, but yeah. Okay. Um, so let's go through the so we've talked about the first two and the very last line of the program. What does line 30 do here? Get pound one comma a dollar sign. Okay. Huh? The first character. Okay. And well, get a character. And so what does the one indicate here?
The second character.
Mm.
Well, you said get is getting one character.
Gets a single character.
I'm guessing it's the first one.
Well, it starts with the first one, obviously, but that same command is going to get used for every character. And I know that because look what I'm doing. I'm looping back to it. So this is going to read one character at a time as I loop through.
Is that how much you're incrementing by?
No, but that is, it happens to be that value, but that's not why there's a number one there. Why is it a,
Get one character.
nope, it's not that. Why is it number one? Which file am I working with? I'm reading from file number one,
Oh.
right? This is why we give each file a logical number, 1 through 8. So, right, okay, because then look, when I'm printing later, I'm printing to file number 2. Okay, so the pound one or pound whatever specifies which logical file number I'm reading or writing from. Okay, in this case, I'm reading. Okay, and so it's going to be from number one, and that's why I'm using get because that'll read a single character at a time. Okay, and somewhere, and I'm not sure what memory address this is stored in because it's got to be there somewhere. There's a pointer because every time you come to that, it's going to get the next character, so it must be incrementing a pointer somewhere along the line. I just don't know where that memory address is. For our purposes, though, it's not relevant because it just, in basic anyway, it just deals with it. For machine code, obviously, we would have to worry about that. Okay. Okay, so it gets a character from the file. And then what? Well, what could be the case? Well, I've either hit the end of the file or I haven't, right? If I've hit the end of the file, I want to close everything and quit, okay? And so what do I want to do is, how do I know if I've hit the end of the file? Well, I'm going to look at the status variable, and I'm going to look at the 6th bit of it, which is in the 64's place. Okay, so by doing st and 64, okay, that's doing the status 8 bits against the number 64 in binary, and doing a logical and between them. Okay, so a mask. So what are the two possibilities for that result? I either get 0 or I get 64. Those are the only two possibilities, right? Yeah, you're doing bitwise and. Oh, well, okay. So it would look like, let's say that I have hit the end of the file. The 6th bit, 4, 3, 2, 1. I'm putting X's because I don't care what any of the other bits are. For just checking the end of file, I only care about what this bit is. Okay, and that could be either a 0 or a 1, obviously. And if I AND it against, oops, all this, what are the possibilities that I get? Well, what do I get in 7 of the 8-bit positions guaranteed? Because I'm ANDing against 0. So guaranteed, I'm going to get those things, 7 zeros. Okay, and in bit position number 6, what am I going to get? In this case, I would get a 1. Well, okay, either going to get a 1 or a 0, right? Depending on what the original bit was. So I wrote that backwards, like that, right? So if the original bit was a 0, I'd get a 0. If the original bit was a 1, I'd get a 1. So I've plucked out, if you will, just the 6th bit to say, is it a 1 or is it a 0? Okay. Oh, because the far right bit is the 0th bit. Yes. Yeah. Sorry. No. So, yeah, believe me, Time Machine, in addition to the Sports Almanac and dealing with baby Hitler, um, you know, this would be on my list. It wouldn't be as high up as Sports Almanac and Hitler, but it'd be on there. Okay. Okay. So if it's the distinction here is if that bit, the 6th bit, is a 1, that means we've hit the end of the file. And if it's 0, then we have not hit the end of the file. Okay. So if it's a 1, then the result of doing that and will be the number 64. Okay, a 1 in the 6th bit position. Yes? Okay, and if that's the case, then what do I want to do? In this case, what I'm going to do is I'm going to print basically print a null terminator at the end. Okay, we'll see if I needed to have done that. And then go to the end, close the files, and we're done. Okay. What about if I have not hit the end of the file? Yeah, we're going to keep chugging. Now, what I write to the new file, though, is going to depend. And I only had to do this because I can't print a null string. Okay, so what this does is it says, okay, is the character that I just pulled in the null character? If it is, print character number 0, which is the null string. Okay, if it's not the null character, then just print whatever it was, verbatim. Okay. All right. So lines 50 and 60. Are we bothered by anything there or any questions?
It's hard to imagine what the question was like. So it's just taking one character, this pretty much taking one character and either making it a 0 or making it the original thing.
Right. And the only time it's making it character number 0 is if it was the null character to begin with. Right. So it's literally just copying character by character or byte by byte, one file to another. Okay. Yeah. Okay. And then when I hit line 70, I go back to 30, and that takes me to the next character, and it would continue until such time as I hit my end of file marker. Okay. And the disk drive tells me, hey, bro, you've hit the end of the file. Okay. So does that make sense? Yep. We can totally do that. Okay. So what I'm going to do is, so let's open up Vice. Okay. And let me put that over here. And let me put this on the right-hand half. And then I'll just type it in. Okay. So actually, you know what? Let me not do that because let me type it in a modern editor. Oh, wait, it won't be tokenized though. That's okay. All right, so let me just copy and paste it from here. Oops. Okay, so looks like everything's good. All right, so let me save this to, let me go to here and let me make a new folder. And we'll do, what's today, the Feb 1st? Okay. All right, so let me just call this copy.base. Okay, whatever. Okay, so let me tokenize this real quick, or copy it to a D64. So let's just, in Vice, let's just create and attach an empty disk image, and then I'm going to put this disk image, oh, in the file, let's see, it's this folder. And I'll just call this feb1.d64. Okay, and then let me open up Droid. I think it's sorry, is it this one or the other one? 2.5? Yeah, I think that's right. Yeah, okay. Okay, so then let's see, we want to go to Dropbox. This is why I put crap on the desktop, because it's a lot faster to get to. Okay, so I've got that open, and then I saved this to Dropbox, Wabash, teaching, 277, and examples, Feb 1st, and copy.basic. Okay. All right, so there's my file, right? And if I hit view basic, right, there it is. Okay, great. All right, and I'm just going to copy this over to my floppy drive. And so now I can load, oops. well, let's load the disk structure. Oh, sorry. Okay. I have to detach it and reload. Then I have to reattach it because I just wrote to it, right? So what Vice does is when you open a disk, it loads it into memory, and so it's working from memory rather than the actual file. And so if you're writing stuff from Droid, you need to close it and reopen it. Okay, so I'll attach the disk image, and then of course I've got to go back to the freaking other locations, or let's go to home, then Dropbox, then Wabash, then teaching, and CS277, then examples, February 1st, that D64 file. Okay, so now that's loaded, and let's see what's there. Okay, there it is. Okay, so I've got copy.base open. Okay, and I can load, oops, damn it, sorry. Copy.base. Now, it's worth noting copy.base is the entire name of this thing, right? It's of type program file. And so the dot whatever, the Commodore just thinks it's part of the name. Oh, okay. So that's clearly gotten screwed up there. Um, nope, definitely not. So, okay. So that's interesting. Let me just tokenize it and copy it over that way. So the tokenizer um, is, um, I need to move this thing. So the tokenizer was called C64 list, and, or what was it called? Um, where did I put this? Hold on. I think it's on the desktop because I probably copied it there just to be convenient. Oh, here it is. It's on the desktop. Okay. So let me take this file here and I'm going to copy it over to my examples folder and then I'll show you what I'm going to do with it. So, okay. So I want to do, okay. So now I'm going to do wine C64 list and then I want to do copy.base. Oh, it's wine 64. That's right. Okay, and it's going to give me an error. Okay, so let me do actually, because I forget the command. Okay, so what I want to do is I need to say the file name and then I need to say where to output it to. And it's PRG. Okay, so I need to do C64, what did I call it? Example, copy.base, and then it needs to be outputted to PRG colon copy prog, say. Okay. And now you'll see that it's created a file called copyprog.prog, which let's just text dump it real quick. And does that look correct? Yeah, we got triple null at the end, we got 0108 at the beginning, and a whole bunch of other stuff. So does that look reasonable? Yeah, okay. So now watch this. I'm going to tape this program file and I'm going to just drag it onto the window. Okay, syntax error. Oh, it's got that. Yeah, let's do this. Okay. Oh, that's interesting. No, it does not. Um, so why did that happen? That's interesting. Well, that's really interesting, guys. I'm not sure why that happened. So, okay, let's do two things here then. Let's yeah, why did that happen? That doesn't make any sense here. Um, hmm. Well, okay, so I could just type it, right? So let's just do that. I mean, that's a little lame, but and I'll figure out why that wasn't working correctly because that's weird. Okay, so all right, 10 open 188 myprog dot p or comma p comma r 20 open 284 um, at 0 new program 3 pw yeah 30 get number 1 a dollar sign 40 if st and 64 equals 64 then print number 2 comma car dollar sign of 0 colon go to 500 50 if a dollar sign equals null then print on device 2 character number 0 60 if a dollar sign equals is different than 0. So there's no else, right? That's why I'm having to do a second if statement. Okay, because there's no else. So if it's not null, then print the actual character itself. 70 go to 30 and 500 close 1 close 2 end. Okay, look good? Okay, so first thing I need to do is I need to attach a disk image that has something called myprog dot the program in it, because otherwise there's nothing to copy. Okay, so let me create and attach an empty disk image, and I'll just put this on the desktop. Okay, and then let me in Droid go to, let me unload the disk. Let me go back to my desktop. Okay, and let me go back to the desktop here. Okay, and let me just take a program file that I've got here. I think a dump.prog is one that I had made before. Okay, let me open this D64 and let me copy dump.prog over. Well, first let me rename it. So let's rename file to be, what was the, what was it, what did I want it, myprog. Okay, so let me call it myprog.prg. Oops, it already exists. Okay, well, I'll just copy this one then. Oops, copy. Okay, so now it's over here on this side. And if I open it, there it is in hex. All this one is going to do is print hello world. Okay, nothing special. Okay, so then over on this side, let me detach the disk and reattach it. Okay, and this was on the desktop. This one. Okay. So if I list this, okay, then right now there's just my prog. Okay. But if I run the program, you guys can't hear it, but the disk drive is making sounds. Okay. And now it's done. Okay. Now, if I come over here, we now have a second file, right? New program 3, which is what I just copied to. You see how it has the star next to it? It's a splat file. I'm not sure why it's a splat file, but it is. Okay. Now, so this is one thing that's annoying about the Commodore, or at least the original version. If I hit list, I just see my program again. If I want to see what's on the disk, I have to do this, but that removes my program from memory. Okay, so now I have my original, my prog, and the copy, new prog, whatever. Okay, and I can load either one of them. So let's load my prog, comma 8. Okay, there it is. Oops. And it works. Okay, and for that matter, I could also load new prog 3 from device 8. And it's the exact same thing. And of course, I can run it, and it does the exact same thing because it's a copy, right? Okay, so does that make sense? Yeah, all right. So I'm not sure why it's, oh, now it's not showing up as a splat, so that's good. Okay. So now if we view the hex, for example, right, for that file, then notice that this is all in the usual basic format, right? We've got 0108, then a pointer, then a line number, and so on, and then triple zeros at the back, okay? And if I look at my new file, this one, it's exactly the same thing, right? So what did my program do here? I mean, it was supposed to be exactly the same thing. Oh, okay. It just, because it didn't print anything to the screen, okay? So I did run it, yes. Uh, it was a minute ago. I said when it happened, I said you guys can't hear this, but the disk drive's doing stuff. It was when I said that it was running. Okay, so in this particular instance, I did not have it print anything to the screen while it was running. I could have had it print each character to the screen, or maybe the number attached to each character to the screen as it was going, so that we could kind of see that it was doing something. I suppressed that, Joe, just to make it work, right? And okay, so it's copied the file. All right, now, but how did it copy the file? Literally character by character. Okay. And now, is that maybe the most efficient way to copy something? Well, but yeah, in some sense, like literally, how else are you copying a file, right? Like you got to read it in, you got to write it someplace, and if this computer only has an 8-bit registers, then how else are you going to do it? Huh? Did you say screenshot? That didn't exist yet. Stealing a what with the screenshot? Oh, yeah. Yeah. You know what NFTs are? A very good, yes, a very good demonstration of um, the greater fool theory of economics, right? Basically, you're just trying to make money off of somebody else. So at the end of the day, you're trying to, with NFTs, you're trying to find somebody who's stupider than you are, and eventually the gig's up, right? Yeah. Well, it's not really a pyramid scheme, but um, it's stupid. Well, okay. What's the value of anything?
Exactly.
A thing is worth what its purchaser will pay for it.
If you buy an NFT that gets you into like secret club or a club like they're doing now, that's different. Versus you're just buying it just to have it, unless you're gonna buy it and sell it.
Yeah, in which case you're trying to find somebody else who's stupider.
It's like collecting baseball cards.
There's literally no. You can have a physical card though.
Yeah.
Yeah, but the physical card itself, it's just like that you own it in general. It doesn't matter that it's like a piece of paper.
Yeah.
It's like music nowadays. It's like when you have the physical disc, it's yours versus when you bought it from Apple. Apple has a terms and conditions. After so long,
They could just
just
say, screw you. Yeah.
you know, they don't have to give you your money back. It's like video games and server support. They say,
Yeah.
oh, you know, at any point we can take your game back. We can shut down your PlayStation or Xbox. We can do whatever you want. You know, it's not physically yours.
Right.
Not the way.
But NFTs are stupid. So don't do NFTs. I'm also not a fan of crypto because, yeah.
It's here to some fancy restaurant or something. Like I've heard some of them do. Then it's like, okay. Well,
Yeah, but do you have the money to go to pay for said fancy restaurant?
some of the stuff's free if you buy it.
Oh, well, yeah.
You're paying like $20,000 for an NFT.
Yeah. Do you have 20 grand laying around?
I wish.
Yeah, same. So anyway. Okay, so it copies it character by character. Drake, question. No? Okay. So I'll figure out what happened with that screwball, like it didn't save correctly. I probably just messed up something stupid. But because I've used that program before and it worked fine. Okay, now this does bring me to a point, which is to say the tokenizer. So there's really two options, right? Because you can do stuff here within Droid, but you can also do what I did was I used this program called C64 List. Okay, problem one though, it's Windows only. I just executed it though. How? I'm on a Mac. Oh, Vice isn't. But how was I able to run C64 List? Because of Wine. Okay. So what Wine does, it's a thing for Linux can use it too, that basically translates Windows system calls into Mac OS or Linux system calls. And for particularly programs that are kind of like stuff that just works in a terminal, there's no graphics or anything attached to them, it can usually run them without any trouble whatsoever. Okay. And so because Cole, you have a Mac, and is Shane also the other Mac user in the group? No, it's you, me, and I thought there was one other. I think Shane has a Mac. Okay, but anyway, I'll have to help you set that up. The rest of you guys that are on Windows, oh no, it's Jacob. He's sitting right there with the Mac in front of me. Okay, well that works too, right? Huh? Do you remember installing it? Okay, I maybe told you to already, but point being that you would have to prepend it, and so think of Wine almost in the same way that we were using Kimu in 241, where you wanted to run a so it's a little different when we were using Kimu, right? Because what Kimu was doing was sort of hardware translation. It was taking a binary written for x86 or ARM and running it on a different processor architecture. So it's translating the processor instructions. Wine is translating system calls, which is a little different. And does anybody know what Wine stands for, by the way? It's kind of funny. It stands for Wine is not an emulator. So it's a recursive acronym. I love these. Well, Wine is not an emulator. Yeah. So, okay. All right. So that's our copy business. Literally worked line by line. Okay. Nothing too horrible there, and I'll figure out what the heck happened with that the translation, because I probably just hit the wrong flag or did something stupid, but because I've used it before and it worked fine. But you'll notice that the basic format, pun intended, is essentially correct, right? We've got triple zeros at the end. We've got our address at the beginning. We've got some line numbers and pointers, and okay, so I screwed something else up, but should work fine. Okay, now if we can copy a file, can we also change what the destination file looks like based on the source?
Yeah, because you just read.
Yeah. Okay. So what do you think a new program is going to be?
3.
Yeah. I posted a new assignment, assignment 2. Did you guys see that?
Yeah, it looks better than assignment 1.
Well, okay, maybe. Just wait until assignment 3, bro. Right. Okay. So could we write a basic program that tokenizes a basic program? Probably can. Yeah. So guess what assignment 3 is? Yeah. But we'll make it a very simple basic program. It'll just be 10 print hello world, right? Just to keep it simple. Because, okay, let's face it, basic is like the world's worst language for doing lots of serious data processing. Okay. But it's a basic language, right? Okay. Question, preguntas, and or fragens. Yes.
Text for like these next 2 assignments. What kind of template and stuff like this documenting that we could read?
Oh yeah. Okay. 10 print is a little less technical. Okay. I think the things that you're going to want to use are the C64 wiki, and then also I've got some PDFs that I'll post. In particular, you want to use this.
Read the manual. What's a manual?
I know, right? The C64 Programmer's Reference Guide. Okay. Now, a lot of the information that's on the wiki is basically taken directly from here, but I've got a PDF of this and a few other things that I'll post up to Canvas. And I actually found when I went over to what was I looking for? I wanted to see what if we had any books on BASIC in the library, and so I found some, including 2 that are in French.
Oh yeah, you texted that. You're like, this won't help you at all.
Yeah. Now, why our library had 2 books about BASIC that are written in French, I have zero idea. But they're there. Okay. Now, working with the Commodore specific stuff is in general better because not every BASIC version is exactly the same. So, for example, if we were to look at BASIC on the Apple II, particularly later revisions of it, there were different commands, okay, that were added as BASIC matured. Stuff for doing graphics, for example, that weren't in the Commodore version, or at least not this version. But we'll keep it vanilla Commodore BASIC for now because, well, we got to do something. Okay, so any question, preguntas, fragen? Not too bad. Kind of like to know where the rest of the class is, but I guess they all fail. So, all right. Well, because we are expecting a massive snowstorm and potentially ice starting, what, I guess tomorrow at some point. Yeah, I would suggest the following. Pay very close attention to your email, okay, in case I get, snowed in at home and have to teach from home instead of here or something, okay? Basically, under what circumstances would class be canceled?
Power goes out, water
Power goes out.
building,
Power goes out, or the building is flooding, or some other,
tornado in the mall.
right, snow-nado. Right. Okay, so if there's some sort of catastrophe like that, otherwise I expect to see you guys either here or on Zoom. Right. for example, let's say that I have pipes burst at the house. I will be dealing with that rather than teaching because it's a little more
Don't go out.
right.
If you need food or something, get it now. Walmart's already like half empty.
Yeah. Well, I'm stocked up to get through this. I'm good. I got plenty of cans of soup and ways to heat it. So, yes, but keep your phones charged. Like, seriously, right? Fully charged as much as possible. If you're next to a plug, plug it in for the next couple of days because it is entirely possible, especially, because we're supposed to get a bunch of rain and then it's going to freeze, right? And so the real danger here is that the ice on the power lines and stuff freezes, knocks down power lines, we're without power, etc. And then pipes start, right? You know how this goes. Okay, so just pay attention to your email and yeah, okay, good. All right, see you guys later.